Good afternoon, and welcome everyone to today's webinar on Agri-PV. So my name is Dee, and I am the project manager for our Agri-PV event that's happening on the 4th of October this year in Rome. And basically, I'll be here the whole time. So together, I am looking forward to exploring the highly promising world of Agri-PV together with you. And I'm sure we've seen that just in the span of a few years, Agri-PV has captured the attention of prominent market players and governments alike, so I think it's worth delving deeper into. So today's webinar is titled Growing Pains, Lessons Learned in Agri-PV, and it's featuring Konstantin Klik from Zimmerman and Elena Resheva from EV Clips. They're both renewable energy experts and outstanding in their own respective fields, and I'm sure they're really passionate people in the Agri-PV industry. So through their presentations, we will explore some case studies, have an overview of the benefits and costs of Agri-PV, all to help you make more informed decisions in the agri-solar field. So it'll be 30 minutes with 15 minutes time for questions after. So be sure to have your questions ready. And so if you didn't already know, at Solarplaza, we specialize in organizing solar conferences for attendees to share knowledge and network. We also have the Solarplaza consultancy, just a partner for market entry and for solar development opportunities, as well as the Solarplaza Foundation. And here we have our one mission is just to accelerate the sustainable energy transition for all. So I do invite you to visit these on your own time, but let's get to the webinar. So I'm sure for some practical notes for questions, there is a chat box to the right of your screen. We will answer them all. You can just put them all in and we will get to you as well. For technical issues, also use the chat box, just address it to me or to Bo, who is our technical whiz, but you just can't see her right now. And the presentation slides and full recordings will be available after the webinar. So the agenda is we have Konstantin, who will start off, followed by Elena. And I will do a quick introduction for Konstantin right now. So he is a mechanical engineering graduate with a background in research with a specific focus on Agri-PV systems. He's currently serving as a project and product manager at Zimmerman, and apparently lead author of the first dedicated book on Agri-PV, which will be published soon. So that's going to be really exciting. Konstantin, you have the floor.
Thank you, Elena. Dee. Sorry. So yeah, it's a pleasure to be here. And as soon as this works, I will start off. Yeah, welcome also from my side to this webinar here. I will give you an introduction to the Agri-PV from our point of view. First of all, I want to give you a little bit of a company introduction. So we were founded like 1950. We usually come from the agricultural sector. We started with building barns. At some point at 2009, we started our first PV project, and in 2011, the company PV Stahlbau was founded. So since then, we are dedicated to PV substructures. We have delivered our substructures to basically all over the world. Basically on all of the continents, there are some PV systems running on top of our substructures. We are divided into 4 different groups. We have started with the fixed tilt systems, where we have already built more than 8 gigawatts of mounting structures. A few years ago, we added also the tracker systems, so we focus on single axis trackers there. We added our floating systems. With the floating systems, we are market leader in Europe and have already realized a lot of projects. And the newest addition to our portfolio are the Agri-PV systems. In total, we have mounted roughly 60 megawatts of Agri-PV systems until now, and this in the last 3 years. overall, we have delivered the substructure for more than 10 gigawatts of PV solutions. So this is a very quick view to our headquarters. Nice to mention in the top here, we have a little test park. If any one of you is interested to really see our Agri-PV products, we have a lot of them showcased just outside of our headquarters. And if you're interested, please get into contact and we can make an appointment for you to come and have a look in reality, because as everyone knows, in reality, these things look a little bit different than just on the paper. So let me dive into the topic of Agri-PV. Why should we deploy Agri-PV? First of all, which is a, let's say, very European view of the problem, is we have a simultaneous land use for energy generation and also crop production. This is a very important point if we see at how much surface is needed for the energy transition. And with this kind of installations, we will be able to not lose too much of this surface only for PV and be able to still grow some food at the same areas. We can do this because with our systems, we put a lot of effort in the design to minimize the impact of our systems to the soil and the crop below. By implementing these systems, we are able, or let's say the farmer is able, to increase the land use efficiency, meaning compared to a piece of land where there's only PV and next to it a piece of land where there's only agriculture, it's possible to raise this percentage to 180% of the combined use. And as I said, we need to expand our PV in general, and Agri-PV gives the possibility to not do this at the cost of farmland, but make use of the symbiosis of Agri-PV and So why should a farmer deploy Agri-PV? There are some downsides, and for sure the farmer will have maybe a little bit more complicated way of working under Agri-PV plant. But on the other side, there is a lot of advantages that the Agri-PV plant can give to the farmer, and it depends very strongly on what kind of Agri-PV we are talking about. In my presentation, I will focus on overhead Agri-PV for horticulture, in which we have the biggest symbiosis and the most advantages for the plants. Speaking of this, like the Agri-PV plant or the modules on top of the plant are very able to protect the plant from, for example, heavy rain or hail. Whoever has been in southern Germany and seen how apples are grown here knows there is almost over all of the farms for apples, there is hail nets, because if there is a hailstorm at the wrong time of the year, the farmer will lose all of his yield, crop yield. We can replace these hail nets that actually do cost a lot of money and that are a lot of work because they don't last for very long. They have to be maintained and replaced every other year. We can replace this with PV modules and replace this, let's say, single-use, single function thing like the hail net with a multifunction system like our Agri-PV. Further than this, we have a protection from sunburn. Even if this sounds a bit strange, also plants and especially fruit can get sunburn and reduce the quality of the fruit quite significantly. Another point is cold. Also, the temperature can be raised inside an Agri-PV plant, but I will come back to this later and have a very nice picture for you on this topic. Next, of the protection effect, we can also reduce, for example, the amount of plastic. If we are looking, these pictures up here are all raspberries. Typically, raspberries are grown under plastic tunnels. They cannot deal with too much sun. They will burn. That's why they are protected. These plastic tunnels are not single use, but they have to be replaced every few years because the plastic goes bad after a couple of years under the UV, and this creates a huge amount of waste plastic. If we build a PV plant that is designed for 25, 30 years, we can reduce this amount of plastic quite significantly. Another thing is that it's possible to reduce the use of pesticides and fungicides, but also for this, I will come back with some examples a little bit later in the presentation. So to give you an overview of the different systems that we at Zimmermann offer, I prepared this slide. In general, we divide into two different kinds of Agri-PV, which are the dual use or overhead use and the parallel or interspace use. As I said, I will focus on the dual use, especially on this first system on the left here, our east-west system. I want to give you a very short introduction on the other systems that we have. So this is our top row system where we basically have one beam on top of the plants and are very flexible to do whatever on top, like a south-facing system, east-west facing system, or we can even put a tracker. Almost the same as our endless top system, it's just able to span a little bit further. The newest addition we have is our 2P east-west system, which basically is a greenhouse system. So it's very suitable for example, raspberries we have designed it for, but also you can think about herbs or cucumbers, tomatoes. Very different kind of Agri-PV is the parallel use Agri-PV, meaning the farmer is working in between the system and not under the system as in these. Here we have two possible solutions with highly elevated fixed tilt, only on one pole, so you don't lose too much space. Or our tracker solution with the specialty that the tracker is able to go fully vertical. You have basically no land loss except for a little bit safety distance you would keep from the poles. These systems are, for example, very well suited for corn, wheat, or also for animal husbandry. You can very well imagine these things. To go a bit deeper to the Agri East-West system, so this is, for us, it's our most standardized and the most simple system, very well suited for orchards. So everything where the plant lives longer than a year, basically, we have quite little row distances, which is not a problem because anyway, if you think about apples, there is a row of apple trees. The farmer cannot drive in the other direction, so there's really little problems created from having a pole every 3 meters. The system offers a very good protective effect through the east-west system. There is a good weather protection from both weather sides. We are flexible with the design of these systems, so we can basically we always go to the needs of the customer because every farmer will farm differently. Every farmer will have a different row distance, a different plant will need a different height. So we are very flexible on working on this. Now I want to go a bit deeper into one specific project. that is located just close to our headquarters on the Lake of Constance in southern Germany. You see the picture on the top here in the back, the mountains and the lake, beautiful area. We have this, we have our system. Next to the system, we see some other apples which are a reference to compare the results of the Agri-PV system to it. And yeah, the system is also supported by research where they actually have a look at the data to determine how good is the system evolving. I want to give you some facts. So there are a bit over 1,000 modules installed with a total capacity of 300 kilowatts. So it's all semi-transparent modules. We are at a height of 3.5 meters and a post distance of 3 meters. And the crop that is being grown under there are apples. So in this system, we integrated the possibilities for hail nets. We will see some pictures on the nets later, but also there is a watering system integrated because we block, with the modules, we block the water from above, protect the plants from the, let's say, wet leaves, and put the water right to where the plant can actually make use of it at the roots. Further than this, there's some planting wires also already integrated into our system, which in usual practice would be another extra steel construction to do this job. To have some results, these are all numbers we got from the farmer. These are all numbers coming from last year. Very important to say. It's only 1 year for where these numbers are valid, and this year was 2022, which is a year typified by heat and maybe drought is too much, but very dry weather. But we have seen in this year that the farmer actually had up to 20% increase in his apple yield under the modules compared to the field that was right next to it. This can be explained because the modules prevent water evaporation from the plant, but also from the ground. And if there is a lot of sun and only little water, water will be the more problematic for the plant. By protecting this water, the plant will be able to just grow better. I promised you some numbers about the fungicide and pesticide use. So actually, again, reference year 2022. We unfortunately don't have more than this 1 year, but the farmer was able to reduce his use of pesticides and fungicides by 80%. So actually, he told us usually on the fields next to it, he had to go 20 times in this 1 year with his tractor to spray. What was the percentage of pesticide and fungicide? I'm not really sure. But under the Agri-PV plant, he could decrease it to 4 times a year. And this comes from the fact that the plants are dry. They are not so affected by mold. And because of this, the farmer just doesn't need to use so much of these pesticides. This is a few pictures I have taken in the project, and I think they are very nice pictures to actually see the effect of a PV plant. On the left here, you see the reference field. Between this field and actually the plant, there's maximum 50 meters distance. You see inside the field, everything is white. So there's snow everywhere. It's not much, but for sure it's colder. And if you look at our Agri-PV plant, there is no snow. Of course, you can argument there's a roof, but actually also in the places where there's no roof, there is not any snow. This is because of the irradiative heat losses that are on the free field. We have quite a lot of them, and all of them are protected in the Agri-PV field. So you see quite a difference in temperature, and in winter it's not such an important topic, but especially in spring this is something that can really ruin the harvest if there's a late frost. That the plants suffer a lot from this, and exactly this is what can be avoided with the panels above. So I have a few more pictures for you. It's here the same system built over raspberries, another fruit that is very suitable for agri-PV. Again, other perspective. And this is again the same project. Here, as I told you, we see the HailNet integration. So they are here. This is the same project, Crest1. We have these hail nets that can be installed at the time where it's important, because it's only a few months in the year where it's needed, and all of the rest of the year they are usually open to allow for insects to better get into the system. And yeah, so this was already my presentation. I think the time is over. If you have any questions to me, I think we decided to move them at the end of the both presentations, and it was a pleasure, and I will hand back to Dee. Thank you.
Thank you, Konstantin. And I think we'll all remember that you extended an invitation to your headquarters to everyone present. So it's a dangerous game. Next up, we have Elena, and she has a master's degree in European public policy. She is the CEO and co-founder of EV Clips Energy with over 900 megawatts. And they have executed agri-PV projects in the Netherlands, Germany, and Austria. And I'm pretty sure, as she just told me, she's extremely passionate about agri-PV. So Elena, welcome, and the floor is yours.
Hi, thank you, Dee. Just a small correction there. We already have, as we're speaking, over 1 gigawatt. So just a small correction there. So as Dee has already mentioned, we are a Bulgarian-based company, but operating all over Europe, not just in Bulgaria. We have around 1 gigawatt of installed capacity, and markets that we cover, we do our mechanical, electrical, and civil works together with testing and pre-commissioning, and of course OM. So in terms of construction activities, we do cover everything, even some procurement. Another thing that I would like to mention is that apart from agri-PV, as we mentioned, we do a lot of other projects that are commercial rooftops, fixed tilt, trackers, also floating PV. And in the last 2 years, what we have been focusing a lot of effort and resources on is indeed the agri-PV. And I am, as Dee already mentioned, very excited to have to see the change in the perspective and to see that agri-PV is really starting to blossom as we see now. So here you have a couple of projects. You've seen more pictures from Konstantin's presentation, because all of the projects that we have built are indeed with Zimmermann structure. And as Konstantin said, they are the market leader. And from experience, I can say that I can see why. So now moving on to why Solarplaza were so nice to ask me to share with you more about our experience and what we do and what we have indeed learned while working on our first agri-PV projects. And I think here is the right time to apologize for some of the pictures that you are about to see. I'm afraid that the bar is very high with Konstantin's presentation, with all the nice green pictures that he showed. But when we speak about construction in general, and especially construction in agri-PV plants, we can expect a lot of muddy shots. Definitely nothing that's very picturesque. It is, however, important to look at the agrivoltaics from another perspective, the difficulties, the knowledge, the experience, and definitely the lessons that we have learned along the way. as we are all now convinced about the benefits of the Agri-PV project. We have touched upon already on the dual usage of the land, the better performance of the crops that are underneath the panels compared to the ones that are outside the coverage, but there are still gaps, knowledge gaps and experience gaps that we still need to work on. And what I will focus today are a couple of aspects that need to be considered during the planning, the budgeting stages of every project, just to avoid any surprises at a later stage. And I can ramble about this for hours, but due to the time constraints, I will only focus on three main aspects: the crop's life cycle, the soil and the ground conditions, and the structure height that we have already briefly discussed. So what do we need to do when speaking about planning a Agri-PV project? Definitely, the first thing is we need to make sure that the construction activities do not intervene or do not disrupt the life cycle of the crops. And installation activities should and are always spent according to the annual cycle and harvest of the crops. The phases to consider are the ground preparation, the seeding, and of course the germinating. What we can say from experience that in the best case scenario, we would have done all the installation activities before even the ground is prepared for planting or seeding. More likely than not, this is not always going to plan, and it could be because of logistics mishaps, or it could be because of the weather, but it is very likely that installation activities should go in parallel with the crop's life cycle. And we can actually work together, and it is very vital to work together with the farmers to assure that no one is bothering the other. So even throughout the ground preparation, the seeding, and even when we see crops coming out of the ground, we can continue the installation activities. And from experience, we have done it. So it might cause some disruption on the whole process. We might need to stop until the crops are not that fragile to be completely destroyed. And here is a nice picture of our workers that have been doing modules installation, where we already see some apple trees being born, and definitely here it has worked very well, because some of the pictures with the apples and the great performance of the apples are indeed from this project. So you've seen the project during the construction phase now, and Konstantin has shared the results. So I think it says a lot about the positive aspects of the Agri-PV. Another thing that we really have to be very mindful about when speaking about planning and budgeting are the surrounding areas. Of course, we cannot compromise any of the surrounding areas. Here we have a couple of pictures where you can easily see that it's not only the plot where the PV plant will be installed that we need to take care about, but it's also the surrounding areas. Of course, we don't want to disturb any surrounding fields, or definitely not any farmers being annoyed with the heavy machinery that we still need to use in order to be able to install the structure. So it is very important to have into consideration the exact location and very typical for the location aspects and the surrounding areas. The next and second point that's very important to take into consideration is indeed the soil and the ground conditions. Why do we need to take this into consideration? Well, obviously, even though it is very likely to have a very good access, as we have seen in the previous pictures, very likely we won't have such a great access to the field. And also, once the field has already been prepared for plantation, it is very likely that it will be muddy. What will happen then if that is the case? Usually the plots where we would install the Agri-PV have already been used for years for agriculture, which definitely means that the soil will be very soft, there will be a lot of mud, and we need to be prepared for this when we plan the budget and the whole construction site. As much as we want all the fields that we work on to look like this, it is most likely for them to look like this. Even the bare fact that I had to look to Google search a nice field, agricultural field, to show you the previous picture gives you enough. I had no troubles finding muddy pictures. This is something that we have taken throughout one of our projects. So you can see what are the conditions that we work on. Why do we need to be very mindful of this? We don't want to have machinery being stacked. As we can see on those pictures, you have a ramming machine, a bobcat being stuck in the field. So one thing to always take into consideration is the season. So is it rainy season? Is it not the rainy season? It's the soil condition. Has it been cultivated for years? Has it not? How soft or how hard is the soil? Because hard soils can also be problem. You might have rocks there that you also need to be prepared. At the end, we do need to be prepared so we don't have any surprises at the end, that usually those surprises, if not planned in the beginning, comes at a very high cost. With side access, there is a solution. It's not a cheap solution, but there is a solution. That's one way to avoid the mud. Use the special plates that have been designed for side access. We might use those even on the plot itself, where we would install the PV plant. However, those are not that easy to find, especially in some countries. We personally have had problems finding such plates in Austria. Once you use them for a heavy machinery, as you can see, sometimes on the first picture, sometimes you need to have very heavy lorries. They are likely to be destroyed. So this is a very considerable cost driver that really needs to be taken into account when planning a project, and definitely when budgeting a project. Another very important aspect to consider is the structure height. And here I'm not going to go into too many details about how do we define the structure. This is something that's in the expertise of Konstantin. Obviously, we already know that the structure needs to be as high as the plants need it to be. So it really depends on what type of crops we would have underneath. But with the higher structure, that comes at a higher price, obviously. It comes with higher health and safety requirements. This is not similar to working on roofs, but the health and safety requirements are very similar. You need special platforms, usually cherry picking platforms, that also need to be able to move within the field that could be muddy, as we saw. So health and safety, as we always do, comes first, so it should be accounted for. The cost of installation, due to the need of the specialized machinery and the manual labor that could be required, is another cost driver. Very likely, this tends to be neglected, and I would say that although we do have that much experience in installation activities of all PV plants being ground mounted, being floating, being carports, Agri-PV, every project is very different because of the different aspects that we have already discussed. So there is no one fits all scenario or a price. So it's very important to speak to the installer or just have a realistic cost or budget for the installation itself. And of course, the sustainability. We are building power plants. We are all focusing on zero net emissions. Of course, we don't want the machinery that we are using to come at a higher emission. There is also a solution to this. We at Eclipse have already purchased machines that operate at lower emissions. This, of course, comes again at a cost that needs to be prepared. Just to give you some examples of machines that I have been referring to, you can see the height here. You can see that this is definitely something that's not that typical, not that usual, and is a factor to be considered. At the bottom line, what I would say is Agri-PV, we all know how important it is. We all know what the benefits are. Just to name a few, the dual usage of the land is the first and the most obvious one. We no longer need someone to convince us that this is the way to go, but I think that we still have a long way to go when it comes to how to plan and have a very well strategically planned project and how to get it executed. We have seen today that we have enough examples, but I'm more than happy to share with you even more afterwards. Thank you, Dee.
Thank you, Elena. Perfect. So now we have the Q&A time. So if anyone has any questions, feel free to post it in the chat box below. We have a few already, so I'll just get us started. This is for kind of both of you, Konstantin and Elena. So obviously you guys have been working in the field, good pun, for some time now. I'm more curious, how many seasons and cycles have you worked through? And do they each have their own particular challenges? So like say summer, spring, autumn, winter. Maybe Konstantin, you can respond first, and then Elena.
So yeah, we have built our first Agri-PV project in 2020. So there has been 2 full cycles now, and we have overall seen good results. For us as the steel manufacturer,
Sorry, could you turn on your camera? I think we can't see you.
Of course. Now you can
Perfect.
see me.
There you are.
For us, the timing of the project is not such a huge impact as I guess for Elena, because we deliver our steel and put it on the construction site, and until there, usually there's roads and we're not so affected by mud. So I think Elena's perspective will be very interesting on this.
Yeah, definitely. Thank you, Konstantin. So, of course, as I mentioned throughout my presentation, the most important is to make sure that this symbiosis that we are talking about, the coexistence of the agricultural crops and the PV, whether the PV plant has already been built or we are still building it. So the most important factor, although I would love to say that we can only build in summer or we only build in summer when we have sunshine and no rains, this is not the case, because usually, you know, for some of the crops that need to be planted, they do grow throughout the summer. So it's very important to make sure that we respect the life cycle of the crops, and trust me, the farmer will take care of the crops and they will be very angry if you damage the crops. So with regards to seasons, not ideal, but we can work for the 4 seasons. We have worked in winter, we have worked in summer, we have worked throughout rains and snow. It is doable. Of course, it's a matter of planning and planning it correctly, taking care of all the factors that I've mentioned. All seasons come with specifics. So the ground could be frozen or the ground could be very muddy. You need to be prepared. If you're planning your construction to be in the rainy season, then you definitely need the plates, and you need to make sure that you have enough budget or money to make this happen. If you're building in winter, you can definitely build it, but you need to be prepared that you might have some difficulties with the ramming, for example. And yes, Konstantin is right that it's all depending on the planning, and once they reach the plot, then the problem becomes ours. And I can say that again, cooperation between the manufacturers and the installers and the investors is a key.
Yeah, that sounds interesting, and it seems also like the costs will vary depending on the season, but with good planning, it will work out. I have a lot of questions, so I'll go through them. The first one is from Kevin Su, and I believe it's for the both of you. So what are the biggest pain points that you think are preventing Agri-PV from scaling faster?
Maybe I can start here. I think the first and the most important is the legal frameworks that are still missing in a lot of European countries. We do see, for example, the example of Italy, where we have already a legal time frame. So I think it's just a matter of time for the other European countries and the other countries in general to follow. However, this seems to be a very lengthy process. So for me, one of the reasons why we are not seeing that many let's put it that way, not as many as we want to see agri-PV projects, is indeed the lack of clear guidelines in terms of legislation.
Yeah, Konstantin?
I would have said exactly the same point, and maybe a little bit different. It's maybe not even so much the lack of it in general. There are some guidelines by now, but we are seeing they're changing. For me, from the German perspective, they're changing every 3 months. There's always something new and no one really knows what is the key now. Also for permitting, all the people who have to do the permitting at the moment, I would say for everyone who does it, it's the first time doing it, and it feels like no one knows what he has to do exactly. I have seen, I don't do anything with the permitting, but I hear it from our customers, and everyone tells me completely different stories about how easy or how difficult it was, or that in one area they want one document, and then other area, also Germany, they don't care about it. So there is a lot of unsecurity in this at the moment, and this is not only for the building process, but I think also for the investment. Like no one knows what is like really happening. Should I do it now? Should I wait? Because maybe in 2 months it's all different. So this is a very big topic, but it's also a topic that is being worked on a lot.
Yeah.
Yeah, I can imagine. And I guess in your experience, who typically does the permitting?
So it is the project developer.
Okay.
So usually, like how it should usually go is that, let's say, the farmer who has the plot goes to a project developer. The project developer will develop the project and ask us to deliver the substructure. Then the project developer should ask Elena to build the substructure. So there is the project developer has like all the lines in his hand, and we are some of the players being part of this.
Indeed.
Then that kind of ties into the next question. So I suppose there was this person asking about, is there a difference between CapEx and OpEx costs between standard ground mounted PV and agri-PV? From this point of view, I guess you guys kind of have an overview of both.
So Elena, let me answer the CapEx question and you will answer the OpEx question. So yeah, for sure, there's quite a big difference. It depends strongly on how you design the system. We have now talked a lot about high elevated agri-PV systems on top of apples, raspberries. So there, of course, to go to 2.5, 3 meters, maybe 4 meters, you need a lot more steel. So this is one consideration, that first of all, you need more material. That of course costs money. At the same time, usually for these projects we talked about now, we always used semi-transparent modules, meaning for the same place where you could put a standard module, have the same price for the steel structure, you put a module that has the same size and let's say only half the power. So there is, from there again, more costs thinking about watts. But if you now think about all the advantages, like you have to also think about, if I build an agri-PV plant over my apples, I will save a lot of money on hail nets, for example. I have a number from southern Germany where a farmer told me he pays 7,000 euros every year per hectare only for his hail nets. And if you think that our structure stays there for 25 years, and you multiply these 25 by 7,000, you have a lot of money. And if you kind of subtract this from the cost, then you are somewhere closer to a fixed tilt system again. and this is some way how to have a look at it. And I'm sure Elena will tell us something about the OPEX and maybe the installation cost.
Installation costs I have already touched upon are much higher. Obviously, when you have more steel, the higher system you mentioned 2-3 meters, we have had 4.5 meters. Obviously, if you need trees to go underneath, you have to have a very high structure, which usually most of the ramming machines, if we talk about machineries, they only ram the standard ones 4 meters piles. So you can imagine that this pile could be 4 meters above the ground, but they need to go under the ground because you ram it. So installation cost is very high. Also, the manual labor that you have, I have shown a picture where we had to physically do manual distribution of the solar panels because we already saw the crops coming out of the ground. So you cannot risk going with the machine and destroying everything. So you really have to be very careful and very mindful. And the only way to do it, manual labor, which comes at a cost. So for sure, the installation cost is higher. However, I think that nowadays the debate is it worth putting the money? And I think that we all know that the answer is yes. We are all working towards net zero emissions. We all see all the incentives. And although I did say that we have still a long way to have a clear timeline or guideline, clear laws when it comes to agri-PV, we see the incentives and we see that it might not be tomorrow, but governments and local authorities are putting a lot of effort because we are no longer in need to be convinced whether or not we should focus on agri. We have the dual usage of the land, so once you will earn from the PV for the modules for the electricity production, and then you still don't compromise or don't give up on the agricultural part, so you earn both. And yes, as Konstantin said, you have 25 years warranty of the structure. You have the same of the modules, which kind of gives you this tranquility of mind that yes, for the next 25 years I can still do both. And from some of the numbers that the farmers have given, and I have seen it because we did a site visit to one of the fields that we've built, it is true that the crops underneath the panels are performing much better, whether it's because of the shading, the thermoregulation, or the preventing the heavy rains to compromise the crops. It is true that they are performing better. So when it all comes together, yes, installation costs and in general, agri-PV sometimes are twice or even 3 times more expensive than conventional standard ground mounted. However, the return of investment is higher because you still have the two working together.
Yeah, I think that's very, very well said. I can see also for the time, so we'll do one last question now. We talk about cost. Maybe now we can talk a little bit about the profit. So Michael has a question. He asks, is the energy from the agri-PV projects you have built used in your experience, has it been on-farm self-consumption, or can the farmer export the surplus energy to the local grid and receive payment? How has it typically been in your project experience?
Well, basically it's both. So the more self-consumption the farmer has, the easier he will see the business case, because it's always better to not buy the power from the grid for a high price instead of putting it there for a lower price. But at the same time, it's difficult to always use the whole power by yourself. You will again need a lot of extra features like battery, and this makes it expensive again. So in Germany, there are some benefits for agri-PV plants. So for example, if you go with a EEG plant in a high elevated agri-PV plant, the farmer will get a bonus of 1.2 cents per kilowatt. So this is not very much. It sounds very little. It's not so little as it sounds. Maybe it's not enough to really cover the cost, but it is a good bonus to push in the right direction.
Yeah, I completely agree. To everyone else that still has questions, don't worry, we will get to them. We have around 2 A4 pages worth. And what will happen is we will answer these after in like an article, and we'll get to your questions one by one. So that's where all the other questions will go. But for now, I believe we have reached the time of our webinar. That was just the final question. And the final thing would be to thank all our speakers for their time, all the attendees as well. And if you'd like to continue discussion at our Agri-PV Summit on the 4th of October, we have a specific webinar discount code as a thank you gift for joining the webinar. And in the meantime, thank you again so much for your questions. We will answer every single one of them, and we will release an article following the webinar. So thank you, everyone, and have a great Friday and a great weekend.
Thank you.
Thank you for
Thank you.
moderating.